We finished all of page 15 in our packet.
Thank you. We skipped number 2.
Okay, so this is going to be the format of the quiz for tomorrow. It'll just be one page, very similar to what you see on page 15. We're just going to go through variations of these types of problems over the course of today. So you'll see problem involving product rule, problem involving quotient rule, being able to identify when there's a need for implicit differentiation, being able to find tangent line equation. So order pair from the original function, slope from the derivative, and then also problem number 6, where you're going to have to get from position to velocity to acceleration to go make your way down to the second derivative, and then evaluate the second derivative at a specific t-value. Okay. You're going to have to make sure that you are familiar and comfortable with unit circle values. Okay, we'll do some practice with that towards the end of class today. Make sure that you memorize your trig derivative rules. We'll practice those 6 rules today at the end of the class. And tomorrow it's be 6 questions. Morning review at 7:30. Oh, I forgot to give these to you. So I'll give you guys a blank unit circle. And this is the morning review for tomorrow morning, which I'll have at 7:30, but you guys can feel free to sit on the quiz. That's right. But I'll give it to you now as well, just for practice purposes. No calculators. Tomorrow.
Yeah, probably. Thank you. Thank you. I'll do that.
Okay, so let's go to page 17. And let's see if we can work through. Oh, wait. Let's see. So page 17. Okay, so number 1. Before we start the problem in terms of starting with our derivative process, what should we do first that will help us out visually? Yeah, let's rewrite it. Yeah, rewrite it with brackets. So bracket raised to what power? Okay, so that 3 is going to do something and that square root is going to do something. If we merge that together, that's raised to the power of 3 over 2. Okay. So there's an imaginary 2 here, right? Square root imaginary 2. Just like if I given you cube root of or square root of x cubed, you'll write it as x to the 3 halves. Same thing here. Okay, and now the benefit of writing in this form, we now know that there's a need for what? Chain rule, right? There's the outside and inside portion, right? We got to do outside derivative followed by inside derivative. So we take care of that bracket to the 3 halves. Comes 3 halves bracket to the 1 half. Keep the inside portion intact. Then we can follow that up with inside derivative. Cosecant derivative is negative cosecant parentheses, cotangent parentheses, and then u prime. Cosecant of u becomes negative cosecant u cotangent u times u prime. Derivative of what's inside parentheses is 7 goes to 0. Negative pi becomes negative pi. I did some cleanup here by just pushing all the coefficients out in front. So the negative, the pi, the negative, and the 3 halves all in front. And then I have these cosecants that can merge together, right? If I want to multiply bases, I can add exponents. So 1 half plus 1 is 3 halves. Yes, question. Oh, how to get to 3 over 2 here? So you see all these are the same, right? The cosecant 7 minus pi x and cosecant 7 minus pi x. So this is the power of 1. This is the power of 1 half. 1 plus 1 half is 3 halves. Okay, questions with 1?
Negatives. So those cancel if you're bringing pi to the front.
So the negative, it's like negative 1 times pi times negative 1 times 3 halves. 2 negatives cancel out, I'm just left with 3 pi over 2.
Oh, so you like separate the negative from the cosecant.
Yes, yeah, you can do that. All these are being multiplied, so I can rearrange however way I want to rearrange it, right? Yeah. It's just that what's inside the trig function has to stay intact. We can't touch those, but anything outside the trig function, we can push it all together. Right? Okay, any questions with 1? Are you okay with 1? Okay, number 2. Okay, cosine of x to the 5th divided by cosecant x. If I want to find the derivative, I can go through what rule? Quotient rule. That's perfectly fine. Is there a way to avoid quotient rule for this problem? Yeah, bring this up as -1, but we can cosecant reciprocal is
No.
Secant.
sine. Sine. Secant is cosine. Sine is cosecant. So you bring that cosecant up, And then you can just rely on product rule instead. So there's two options. You can either go through product rule by bringing that up, or leave it in that form and go through quotient rule. The answers will look different, but both will earn full credit. But I decided to bring it up, go through product rule because cosine, sine's derivative is a little bit cleaner, easier to deal with than cosecant's derivative. Okay, f prime g plus f g prime. Cosine u becomes negative sine u times u prime. Sine u becomes cosine u times u prime. Not much in terms of cleaning up. I just put the coefficients that I can in front. The only coefficient I can do with the second set of terms there is bring that e in front. Okay, number 3, pretty straightforward. We just go directly into our cosecant rule. Just follow what the rule says. Negative cosecant u cotangent u times u prime. Okay, try that. Okay, the key went to the second derivative, but I'm just going to ask you for the first derivative here.
Like a constant in front of that cosecant, but you just leave it there outside.
Like it was like 4 or something.
Yeah, like -4.
Right, so it's just hang out. Yeah, it wouldn't change at all. It's just hang on. Next question with 3. Okay, take a look at 4. Okay, take a look at how number 4 is set up. And you identify 2 things that we got to make sure we take care of. product and implicit good. So x and cosine y, those are two distinct terms. We got to go through product rule there. And also you see y is kind of inserted into the equation here. It's not by itself. We got to do implicit as well. So we got to take care of both things. Make sure we take care of both things. Apply both those properties or both those concepts in our derivative. Okay, try that. Okay, we know we got to collect our dy dx's as they're going to pop up when each of these respective derivatives are going to be applied. So that's the only calculus step there. Everything after that, you're just adding, subtracting, trying to get that dy dx by itself. So the derivative of tangent is secant squared u times u prime. Okay, so I moved terms around, get the dy dx terms together, factor dy dx out, and then divided the rest over. Now this is perfectly fine, leaving in this form, but just to let you know that if everything is negative, you could factor a -1 from both the numerator and denominator and clean it up a little further and just change the sign of every term. The reason why I want to share this answer choice with you is on AP exam, if this is a multiple choice question, if you got this as your answer, the multiple choice choices will look more like this. So just have to make sure you know how to get from your answer to this version if there's a difference between what you get and what your option is. Okay, number 5, y equals 2 tangent cubed of x. Evaluate y prime of power 4. So this is asking us to find the derivative and evaluate the derivative at power 4. What should we do first, though, before we jump into our derivative step?
Green brackets.
Yeah, let's put that 3 outside in the set of brackets. If you don't do that, it's just harder to get to the correct chain rule. But having that bracket cubed visually, I think it's a lot easier for what we want to do with chain rule. So once you identify that there's a need for chain rule, that there's an outside portion being 2 bracket cubed and inside portion being tangent x, we can take turns with each derivative, right? 2 bracket cubes derivative comes first, and then tangent x's derivative comes second. Okay, so 2 bracket cubed becomes 6 bracket squared. We leave the inside intact, but we took care of the outside's derivative. Now ready for tangent's derivative. Tangent u becomes secant squared u times u prime. I left the u prime out because x's derivative is 1, so I know that 1 is not going to change anything. Okay, what's next after we find the derivative? Plug in pi over 4. But something that we can do to make it a little bit easier to evaluate. What can we do to rewrite this to make it a little bit easier to know the order that we're going to work things out? Yeah, so yeah. I think writing that secant as bracket is also helpful because the bracket is good for when you're about to do chain rule, but it's also good if you're trying to evaluate, because if you put that power 4 in for that x, you may not know which comes first. Okay, but you really want to understand that it's secant of power 4 that comes first, and then that result gets squared. So I like to rewrite that secant x with a set of brackets so that I'm not confused in terms of the order that I'm going to apply those things. Okay, so now we got to work in our unit circle knowledge, right? So tangent of power 4, what's that going to be? Just 1, yep. And then secant of power 4, that may not come as familiar to you, but we know something related to that is cosine, right? Cosine of power 4 is root 2 over 2. So if we know cosine's power 4, then we should know what secant of power 4 as well. We just take the reciprocal, right? 2 over root 2. So we insert those values, and then we can square each respective ratio. Any question with 5? Okay, take a look at number 6. Find the equation of the tangent line for the function 2 secant squared 2x. So tangent line equation, we're going to find our order pair from the function. Next, we're going to find the derivative, then evaluate the derivative at that point to find our slope, and then point slope form. Let's go ahead and find the derivative first, just get our calculus out of the way. What would you do though before you jump to your derivative step? Rewrite it, yeah. Now, would that bracket include the 2, or would it not include the 2? Not include, right? So that bracket is just around the secant 2x, but it's not going to see the 2 in front. Okay, chain rule. Identify your outside and inside. Try that, see if you can find the derivative. 2 brackets squared becomes 4 bracket to the first power. Secant parentheses becomes secant u tangent u times u prime. I clean things up a little bit by merging the coefficients together, merging the secants together. And now I have a source for me to find my y value and also a way for me to find my slope. So to find your y value, insert the pi over 6 in for the x, and see if we can resolve that down to a numeric value. Make sure that you're not finding the secant of pi over 6. That 2 is in front there, so it's actually secant of what? Pi over 3. If secant pi over 3 is not familiar to you, think about cosine. What's cosine of pi over 3? Right, 1/2, right? So secant must be 2. Yeah, flip that 1/2 around. Yeah. Okay, slope comes from the derivative. So insert pi over 6 in for the x's within the derivative. Secant pi over 3 is 2. Tangent of pi over 3 is √3. Put all that together, you get 32√3. My order pair is pi over 6, 8. My slope is 32√3. And then finally, point slope 1. Okay, last 2 things that I want us to do in class is practice writing out our derivative rules. So don't start yet, but take a look at those rules. And after a little bit, I'll cover that up and have you guys write down these 6 rules that you can have at the top of your page when you get your quiz tomorrow. And then after this, I want us to just do fill out the unit circle. And then there's also a back that you can do later for if you want to do that additional practice. Okay, remember, all the C functions are lined up on the right side. They're in alphabetical order. They all have negative coefficients. Tangent and secant, they only involve each other in terms of the derivatives. Cotangent and the cosecant only involve each other in their derivatives. The ones next to each other kind of have a similar format, similar look. Okay. Okay, let's try them. Okay, check how you did. Hopefully with the practices that we've done leading up to this point, you have done it perfectly. Hopefully you're really close to it, so. Okay, so last thing I wanted to do is to fill out one side of the unit circle, just so you have that confidence knowing that you can find any unit circle value. If I ask you for cotangent of pi over 3 or sine of pi over 4 or cosine of, 7 pi over 4, that you can quickly get all those values that you need from the unit circle. Well, tomorrow I'll provide you a blank unit circle on the quiz, but I'm not going to grade the unit circle. It's just there for your reference.
That's one quadrant, right?
Yeah, go ahead and fill out that one. see some of my pre-calc students mix up the order of the second and third quadrant. So just remember that, well, first, make sure that your first quadrant is good to go, right? If you mess this up, then it's hard to recover. But make sure your first quadrant is good, and then just remember that anything closest to the x-axis is going to have a similar numeric setup, right? So the closest measures to the x-axis will all have the same numeric order pair. And then the pi over 4, the middle diagonals will be same order pairs. And then the furthest away from the x-axis is the same order pair. And just the only difference then is your signs. Right, and keep in mind that your x value is your cosine. And then your y value is your sine. And then your tangent is sine over cosine, or in other words, y over x. Right, so tangent of pi over 6 would be 1 over root 3. Always cover up the denominator and just divide out the numerators. If you need more practice with unit circle, then see if you can practice through again. And I provided a back blank copy for you to practice if you would like. Okay. All right, so tomorrow's quiz, 6 questions. Then you'll see product rule, chain rule, implicit, quotient rule, Einstein equation, and then PVA, where I asked you for acceleration at a point. I'll give you a blank unit circle, no calculators. Make sure you memorize your 6 trig derivative rules. And I'll have a morning review tomorrow at 7:30. Okay, all right, don't get your phones.
It's pretty close to how the quiz will look.
Yeah,
Page 15.
yeah, the picture for this. This doesn't have the Einstein equation.
Okay,
and the PVA.
thank you.
You had a trick that you remember the means.
Yeah. Everything is gonna stem from 360. Things represent anything that's close to it, you're gonna either add or subtract 30 degrees. 180 minus 30 is 1 plus 30. 360 minus 330 is 50. In the middle angle, you're gonna be adding subtracting 45 degrees. 180 minus 45, and then plus 45. On the front goes away on add or subtract 60. 180 minus 60, 180 plus 60.
So long.
I was here Friday to show you my homework.
Okay.
Here's all 3 of it.
All right, great. I'm marking it.
I got them all right.
I got like a 0.
Like I'm just gonna.
What do you think? Not laughing. I think I was here for the greatest thing. I just could not laugh. I don't remember what was going on. I have to see all. I swear like we dropped up. I don't remember what.
You know, it's still like the library. I don't remember. No, but when he said that the accident.
Think about it. Oh, that's good. Said like. Yes, I got you. But just worry about
I don't know, probably like, stop doing it.